Okay, so my name is Bojan Gavrovski. As you can see it, it's over there. If you saw the picture of me, that's me like 15 years ago. So like this is how I look like right now. I'm the founder of Beyond Basics, which is a small software company here in Macedonia. We mainly deal with R&D and we deal with SaaS products. And the other thing that I'm doing is Oblax.io, which is our small, very small startup that actually is the inspiration for this talk today. So to get this started, okay. To get this thing started, like I want to tell you first, like this is a disclaimer. So you're all smart, and I know that you know a lot of things. You probably know a lot of things more than me, and I like whatever you say and do, like it's the best thing most of the time. So bear with me. So I started in the late 90s, where the landscape was kind of different than it is right now. So we had three major browsers. Maybe you can recognize them. Maybe some of you can recognize them. It's Internet Explorer, Netscape Navigator. We had Opera. Back then, CSS was not really a thing. Like we had like 2 CSS rules, nothing more than that. And JavaScript was for form validation only. So actually, almost no JavaScript. We had this thing which was the browser wars, where like these 3 guys were fighting each other, and that's when I actually started like getting interested in how the web works. And these 2 tools were my first tools that I used to build websites. So the one on the left is called Dreamweaver, and the one on the right is called FrontPage, and it was made by Microsoft, I think. And there's an interesting thing that. The internet was extremely slow back then, and now, for me to be able to share my websites, I used to put them on a floppy disk and share it with my friends, so they can like run it locally on their computers. Okay, so then one day, a friend of mine, which I really like appreciated and thought that he has a lot of knowledge in computers, said, listen, there is this thing called Linux, and Linux is used by hackers, and I wanted to be one. So next day, I had Linux, I had Windows, like dual boot setup, and to be honest, there wasn't like much you could do with Linux back then, because like it was like the shell and not much to it. So you could learn how to use the shell, you can learn how to use the commands, and also, you could start programming. So I started using VI, not Emacs, because that was for nerds. And there was, like, Linux was the perfect tool, the perfect toy for a person like me. There are a couple of things that I learned then, and they, like, stuck with me along the way. And I learned that, like, there are a lot of tools in Linux that do, like, one thing only, and they do it well, and you can combine them to get like better results or more robust results and combine them for power. So I got into web development. How? Because I learned that there is something that's called the CMS, Content Management System, and this was used to update the website that you have like automatically, instead of just like updating HTMLs and sending to the server via FTP. And then I started learning Perl, and I hated it because Perl is a language that is kind of problematic. Like you hate it while you write it, and then you hate yourself when you're reading what you wrote. But then one day, I came across to a website that had a .php3 extension, so this was like a new programming language for me. Like it was not Perl, and I like went into it, like tried to learn what it is. It was PHP, did the whole thing, like installed the LAMP stack, started writing code, and it became my daily driver. So then I started like thinking about building different websites. So I started with backend programming, some simple forms. So each site basically used the same code because I just copy-pasted it for every project. And when I started to build my own website, my own portal, I really didn't have the money to host it, because back in the early 2000s, having a server and having a hosting was like basically you would have to sell a kidney to get one. So there was this thing called Mnet, Arbor.net.org. It's still up, it's still working. And they would give you like 10 megabytes of space where you can actually put your website. And instead of having like a regular database, SQL or NoSQL, whatever you use right now, I would use text files. And I could probably do like a complete talk on just that, but like another time. So I really learned to work with what I had, like with the tools that I had. This is one of my first websites. It's called pmf.cjvs.net. It was hosted on Mnet ArborNet. And if you can see, the date is 2002, and this is the second version, like the redesign. So yeah, it doesn't look that good by today's standards, but it was actually cool. I started doing like different websites, started writing my own CMSs, my own frameworks, and like I really got into code reusability, because like I learned that basically whatever you write, you can reuse it on another project. So after time went by, I started seeing like these patterns that basically either you will copy paste it or you will like write the same code or whatever, and at the end of the day, it's all CRUD. Or maybe not CRUD. Thank you, guys. Maybe not like the whole application, but 70% of each application that you would own, like you would take ownership of, is going to be CRUD. So create, read, update, delete for the uninitiated. So this is basically where we are with web right now. You have your UI, you have your API, you have your DB, and then like for the UI, you can have web, you can have mobile, desktop, TV, or AI agent. Or for the API, you can have like all these protocols, and for the DB, you can have SQL, no SQL, you can have like whatever, maybe text files. I don't know, whatever you like. And the most important part is the part in the middle, the API. And there are some guys here that would say that you don't need APIs. I know. I'm all for that. But each API has a handler. And like we do this dance all over again on each project. Like you do the handler, you do the data model, you do the validation, you're gonna do like the SQL queries to read and write from the database, you send the output to the front end, whatever that is, and like we do it like over and over and over and over again. So almost every backend is a CRUD. So we are kind of stuck in this loop. And if I give you this is our mystery JSON. And you have your ID, your headline, your image, your content, your publish date, your tags. Can you guess where's that from? Like, I'm asking you. Just shout it out or raise a hand or whatever. Blue sky, okay. Something else? What can it be? Okay, one more person. Instagram, okay. It can be Blue Sky, it can be Instagram, it can be whatever, you know. So it can be Facebook post, it can be Medium post, it can be, what is this, Twitter post, it can be an Instagram post. Like, why? Because it's the same data object, you know. We are writing the same software over and over again. Like, these 4 companies, although I know that Facebook and Instagram are like the same thing, but these 4 companies could probably use the same CRUD in the backend, and like nobody will notice. And does it even matter? Like, doesn't even matter that it's like that. What matters is that somebody will say, well, this is an old problem, you know, this is an old topic, and we already solved it. Have we? Have we really solved it? So let's see our failed solutions. First, we tried scaffolding. And I remember mid-2000s, DHH presenting Rails. It was magic. Like, he writes one command, generates the model, generates the CRUD, generates the UI, generates like the whole thing. Like you basically just execute one command and you can go and just start using it. Like you have an application. But code was not very flexible because it was generated. Then it's framework dependent, of course, Rails. And then it becomes hard to maintain because what happens when you upgrade the framework? And if you cannot maintain, then you have some security concerns, which is like normal with outdated software. So let's see our second solution. So open source software. And I'm all for this. And it's really important for you to support open source. That being said, open source sometimes can be too bulky. Like, you need like one little tiny thing, and you get like a whole framework, and it happened like over and over again in many different projects. Or maintenance stopped. Like, maybe it's too popular, there is only one developer, they cannot keep up, and you might like get this number of issues. This is all fake, but I'm sure that there is a repository that has this. Or there is no documentation because the developers are focused on the code. They're not focused on the issue. I mean, they're not focused on documentation. So that's a problem. And if you have time, either donate your time or money to an open source project that you're using because the developers need it. And now, the AIs. Like, how many of you are using AI for coding? Well, it does help you write more code. That's true. But as with everything else, the code is not always the cleanest, number one. Number two, not always the right code. Like, it's not always the thing that you wanted because you probably were not able to like get into details to explain it, what to do and how to do it. And it's really hard to debug, sometimes. And there's also this thing here. You remember this thing from 2 months ago? When this guy used Replit and he deleted his production database? So next time you use LLM and tell somebody else that they should use LLM for coding, ask yourself whether you like your bank, the developers that work in your bank, to use an LLM for the code. For your money transactions. I mean, if you do, then I'm okay with it. And as a side note, it's not just code that you need to take care of. You ain't gonna host it on localhost 8080. So you need some kind of cloud infrastructure or whatever, maybe just a server. And you might say, like, it's a DevOps job to do it, but is it really? Like, if you write bad software, let's say you write a bad Lambda function, and it turns out that you ran your startup out of money, like there's no money left, because your AWS bill is like too high right now. Yeah, it's your job. So mistakes do cost a lot, and infrastructure is hard. So how do we like manage all of this? So it's an arc, so please bear with me, because it's going to be like a complete line of what happened and what's happening and what will happen in the future. So we first started off with monoliths, which was great. We had monoliths, we had one code base, everything was there, nice and cozy, until it wasn't. You know, because you have like 20, 30 developers submitting code into one repository, which is not a problem, not at the beginning, but as the software grows, it becomes a problem. So we said, okay, let's split it up and do SOA, service-oriented architecture. And we ended up with a bunch of monoliths, still monoliths. And then somebody came up with microservices, which is, I don't know if I could curse, but if yeah, microservices. And what did they bring us? Well, they brought Netflix, Google, and Dropbox a lot of users because microservices were scalable and like all of that. But not for small, underprepared teams, which made a lot of anti-patterns when it came to microservices. Because microservices are actually hard. Microservices are problematic when you have a small team. And microservices are not driven by scalability or, I don't know, something else. They're driven by organizational structure. So if you have like a huge company and you have 100 teams, you can assign, I guess, 2 microservices per team, and each team can document them, and they will work like on this one thing that they have, but not more than that. But if you have like 5 developers and you have 200 microservices, then you have a problem. So the microservice rule that we forgot, like in almost all scenarios, was do one thing and do it well. And of course, the separate databases and all that, but I'm not going to go into it. So we went from monoliths to service-oriented to microservices, back to monolith. And like we learned some patterns, hexagonal architecture, I don't know, ports adapters, things like that. Like, and our code is now more layered, but it's still a monolith, you know? We wanted to go away, like we wanted the monolith to go away, but now we're still stuck with the monolith. Well, I have a solution if you want to hear. Rejoice, microservices are good again. But how come? If you remember the Linux story from the beginning of the presentation, we had this idea of having a lot of CLI tools and like connecting them all together. And each of those CLI tools would do like one thing and would do it well. That means that historically, this has been proven that it's the correct approach. And now, if we turn to the current state, there are a lot of micro SaaS startups. And if you haven't heard the term micro SaaS, it's because, I mean, I don't know why you didn't have, you haven't heard the term, but micro SaaS is basically small startups that do a small SaaS product that does only one thing. So if you take away the UI, you'll end up with an API that actually makes only one thing. Sounds familiar? It's like a microservice. And microservices are actually not that bad, you know? Because the idea was have one service, do one thing, do it well, and like doesn't care what the others do. So if we have enough, and this is my term, open microservices, and we compose them, we won't need to write the same old CRUDs ever again. Because if you remember, we have one service that's generic enough to host an Instagram post, or a blog post, or a Facebook post, or a tweet, or a Blue Sky post, or whatever. And it's so generic that you could just plug it into your application and just start using it. Like you would do with an NPM package. Like, if you trust an NPM package, why wouldn't you trust an already running service that you don't have to compile or write or whatever? So, we may have a manifesto. And it has 9 points. And can we see the counter? Okay. So, the 9 points. The first point is do one thing well. Why? Because each service should have a single sharp responsibility. When a service tries to do too much, it becomes harder to replace, scale, and reason about. Like, you have one vendor, they do one microservice, and that's it. And this one does not rely on other services. Why? Because this is probably the most problematic thing, a vendor lockdown. If you have like one sharp responsibility per service, and I create one service, and you create one service, and the guy in the back creates one service, and somebody else comes and compose them to create like a larger application, there will be no vendor lockdown, because I'm not saying, well, I'm dependent on his service, you know, so you would need to use his in order to use mine. So another thing would be idempotency, but this is probably a given. Like for each same input you do, you get the same output for the microservice that you do. And then the authentication. So this should be a bit familiar because we already have systems that do authentication for us. We're gonna need something RSA-like, like public-private key, like token created with a public-private key. So whenever a token is issued, you can also access the public key, so you can validate the token on different places, on different microservices. And this is also important, data storage. So this is where basically my definition of open microservices differs from microservices, or basically upgrades it. In this version over here, the microservice can take credentials for a database. So instead of sending the data into its own database, like the microservice database, it will send it to your database. So you have the ownership of the data. So I provide a microservice, but you tell me, listen, you're not storing the data in your database, you can store it in mine. So basically, I will create the tables in your database, and I will store the data there. Probably a separate database from everything else and all that. Then availability. Since we're gunning for availability like all over the world, we need to run all the microservices like in different availability zones. So I can run it like in Europe, I can run it in East Coast, West Coast, Asia, South Africa, wherever. So it will be closer to my on-prem database. Of course, ACL, because you need access control lists. And this should be configurable and should be reading from the token that your authentication service actually created. And then to be able to know when a change happened on the system, every service has to have a webhooks mechanism. So basically, it will notify other services that something changed. And last but not least, and maybe as important as everything else, is documentation. Because all the services are really small now, you can really easily document them. So that means that when you have like an API service with 8 endpoints or whatever, it's really easy to document 8 endpoints instead of like documenting 1,000 endpoints and just maintain that documentation. So there are a couple other things here which are worth noting. The protocol by which a service is accessible is left to the developer. So if you want to use REST, use REST. If you want to use gRPC, use gRPC or whatever, whatever you see fit, or whatever you think your application or your microservice actually needs to use. Because there are different use cases for each of the microservices. And service developers do not develop SDKs, just documentation. Why is this important? SDKs should come from third-party developers. Basically, an SDK should be like a framework that sits on top of different microservices. So I, as an SDK developer, would take your microservice, your microservice, your microservice, your microservice, your microservice, et cetera, and just create an SDK that will work with all of them and basically provide a framework to use all those microservices. And this is how it probably would look like. Like you have the client application UI, then you have the SDK by vendor F, and you have like all these microservices that do one thing only, all by different vendors. And then you have the application-owned database. So it's not a database of the category service or wishlist service or warehouse service, product or cart, but it's a completely different database which is hosted somewhere in the world or on-prem where you have access directly to your data. Of course, by database, I'm not saying like the database, the schema itself. I'm talking about the database server or server. So how do we make money off of this? Like it's interesting because you can. How? The standard methods. You can do time-based, like monthly subscription. You can do feature-based, like pay once for a certain set of features. Or you can do pay as you go, which I really like because like it fits the philosophy. Because you only pay for what you use, and that's basically it. And this is the bonus. LLMs might not be the greatest at code. Although they do write code, I would say that it's not the best code. But they make a pretty good UI. Why? Because all of you write prompts right now. And that's the UI for communicating with computers. And if you just employ like MCP protocol on all your open microservices, now you have services that can work with LLM agents and MCP clients, which is actually great, which now we cover the old world and the new world at the same place. And will this actually work? Of course it will. I mean, probably. We have Code Zero, we have super tokens, we have Firebase, we have Contentful, we have Sanity, which are, in turn, either BaaS, backend as a service providers, or they are API-first companies, API-first products. So that means that you can give your APIs and expect for people to use them, because these guys do. This is like, that's their business model. And the solution would be, like, reusable services are better than reusable code. If you have a running service that already does its job, why would you do it again? If it's out there, and you can just tap into it, and you can send data and read data from it, why would you write the same thing again and again and again and again? And there are a lot of people that will say a lot of different things. But if you write that service as generic as possible, as modular as possible, as extendable as possible, this is really possible. You can do this. And you won't really need to do NPM installs anymore to install like different libraries to do certain things for you. And this is why we're actually building Oblox.io. And this is not a pitch. This is like something that I really want to share, because Oblox.io is the inspiration for this talk. So the things that we said so far. CRUDs are essential, but also boring and a waste of time. We tried fixing it with scaffolding, open source, with AIs. Doesn't work. Like, doesn't really work. Like, it works, but not in the way that we expect it to work. We went from monoliths to microservices and then back, and like, I don't know where we're going to go after this. And why not vendor diverse and wanting only services? Like, it's there. We already used it. We have microservices. We have micro SaaS. We have like all these things that prove us that it's possible. And if you add an MCP, then it becomes AI ready. So the new world is here. And having headless and API-first products means that we can actually do this. This is viable. Like, this can work. And as a last thought is, reusable services are always better than reusable code. Like, if you have one service that actually does the job, why would you write it again? If it's out there and you can use it, why would you write it again? It doesn't make sense. And that was my last slide. So, okay, so thank you. Thank you for your time.